Good morning, my superhuman friends. I hope you are ready for a much more relaxed live stream this week. It was kind of intense last week, going through all that legislation. I don't want to do that sort of thing too often. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, okay. The topic for today is James Kennewell's amazing SuperHouse sign, which he made with custom PCBs and hand placing, I think it was something like 315 WS2812B LEDs. So it's a fantastic contraption. But first, good morning to everybody that's here already, right for the kickoff. We got Mako, Longflare, Chip, my old friend from school. Austin is here, Andy, Frank. Lots of people. Oh, Matt Smith is here as well. So, and also just before this started, I got another message. Sorry, no. All right. Good morning. It's just over midnight. Andreas. Yes, just over midnight for you. And in Greece, which I think has just gone to daylight saving time, that means it is now, for Apostolos, it is now 1 a.m. Yes, okay. So I just messaged Apostolos earlier and said maybe I should do some live streams in the evening, which would make it morning over in that part of the world. It might be a little bit less painful. I don't know. Sihon does his live stream starting at a dark o'clock in the morning so that it's not so bad for other parts of the world. But yeah, 10 a.m. start for me for a live stream on a Sunday is a nice relaxed beginning. I'm actually in here, yes, it's, as Frank said, it's 10 a.m. Melbourne. EU is changing tonight, says Mako. Yep. Okay, where to begin? Where to begin? All right, so the sign that James made. Let's just switch over to, where are we? Overhead view, and we should be able to see it. So I've got it sitting here on my bench. Let's do a quick recap, because it's been a while since we've looked at this, and I need to get clear in my own head what the issues are and what's been tried and what we can try again. So this is going to be a bit of a collaborative debugging session. We'll see if we can find out what's going on with this sign. Now, quite a while ago now, James made me this amazing sign. And I'm going to grab a couple more bits and pieces to show you how it all goes together. So, this is the frame that it goes into. Let's jump back to here. Okay, so it goes into this frame. So he's made up this timber frame and stained it and put this diffuser sheet in the front, and the sign fits into the back of it. Okay, I'm going to turn off the power supply so I don't make anything go boom. Undo this. I'm going to kind of partly reassemble it just so that you can see how it all begins. Now, which way around? I don't know, and I don't know that it matters. All right, so this is 3 PCBs. So Super is 1 PCB, the logo is 1, and House is 1 PCB. And they are attached to this timber frame. And then that frame fits down, face down into, does it go that way? No, I think it's slightly asymmetrical, so it probably only goes one way. That's it. And then that fits down into that frame. And the result is that the sign, oh, it's upside down. The sign is visible through the diffuser. And there is a Wemos D1 Mini up the end here. This is the brains of it that's providing the pattern and controlling all the LEDs. And then there are these little voltage regulator modules. You can see a few of them still stuck on the back here, and there were a few others as well. And the idea is that there was a socket just here. I took some of this off while I was doing previous debugging. So there's a DC jack that goes there, and then what you do is you plug in a power supply, which could be, what was it? I can't remember what the power supply was. Might have been 12 volts or something. And that then feeds into all of these voltage regulators, which also power the D1 Mini, and the voltage regulators provide power through the back of the PCB to all of those LEDs. So the result is that the pattern on the display can be controlled by the D1 Mini. Now, it actually works really, really nicely if the brightness is turned up. So well, let's have a look at it. I'll show you the deal. Now, I've got a, as part of trying to figure out what was going on, I've bypassed all of the onboard voltage regulators and I've just ganged the power cables together. This is power from a lab power supply, which is sitting up here. So I'll connect that back onto it. Bring it around, turn on the power supply, and you can see that it illuminates. Now you can also see that at the moment you can't really make out the letters very clearly in the words, like in Super and in House. It's kind of a blur on the camera. I can read it quite clearly just looking at it with my eyes, but on camera it doesn't show up very well because the intensity is a bit too much and the camera picks it up more than it needs to. And also I think in combination with the diffuser, that tends to make it a little bit less clear. So the solution to that is to turn down the brightness. Now, where can I stick this? I'm just going to balance it there for now. And let's go to the desktop. Oh, fantastic. We can see the UI and we can see the sign all in one go. So this is the WLED software, which is running on the D1 Mini and controlling it. Now, if I come along to the color wheel here and just click somewhere else, let's go green. So you can see the color of the sign has changed because I've clicked in that color wheel. Let's make it go like a yellowy orange, make it go blue, and you can do different patterns and all sorts of things. And it's looking pretty good. But this is the issue. Now, can you see this? I'm going to have to move this window a little, just a little, bring it in narrower. All right, you see this slider up in the top right? There's a brightness slider. If we turn the brightness up, it gets brighter, obviously, but less distinct. So what I was wanting to do to solve the problem of the oversaturation of the sensor on the camera was to bring the brightness right down. So if we bring the brightness down, it begins to improve. You can see it's getting a little bit sharper there. It might be a little bit hard to tell. But then once we bring the brightness down to a certain point, how far down do we have to go? Well, you can see the effect starting to happen there. And it seems to vary a little depending on the color as well, the color that's displayed. So what you can see is that I've turned the brightness down and now the word super is nice and clear. Let's go back to that front camera. Okay, so now the word super is nice and clear. House is pretty clear right up until that point, somewhere around there. And that's because the LEDs are just barely on at the moment. They're turned down a long way. So this is the sort of level of illumination that I need it to work at in order to make it clear on camera. And then I can stick it up on the wall somewhere. But this is what is really baffling me. That's what I'm trying to figure out. Now, I'm going to change it to a different color. What'll we use? Maybe red. Yeah, that makes it fairly distinct. The thing is that there are many, many different things that could be causing this. Could be software, which is not very likely, but it's possible. Could be hardware. It could be something to do with the obvious candidate for this is the power rails. And there are no caps on these LEDs. So normally with WS2812B LEDs, what you need to do is put a capacitor, typically like 1 microfarad or something, across the power rails right next to each LED. Because the LEDs tend to be very noisy. They've got built-in PWM drivers, which means that their current consumption is very spiky. They're chopping the input voltage in order to achieve the control over the level of illumination. So having capacitors at every LED really helps with that. It helps smooth out the power supply across the whole string of LEDs. So there are no capacitors on this at all. So the obvious candidate for what's causing this is something to do with power. But what exactly is going on is the question. And that's where we can start digging in and see what we can figure out. Okay, so the other thing that sort of baffles me a little bit is the position changes. So even there, like, I'm not touching anything right now, I'm not changing any settings. You can see that the flickering position varies. Sometimes it's there, sometimes it's there, sometimes it's over here somewhere. Like, it moves around. So it's like there is a failure that is occurring somewhere in the communications between the LEDs. Oh, and also something else I should point out for people that haven't played with these before. These LEDs are in a long daisy chain string. So the way this works is that you have one LED has an input and a power supply and an output. And then the output of that goes on to the input of the next one. So what you do is you treat it like a long sequence or a series of dots, and you send data in the start, and then it sort of ripples down the line. So if you have a problem like a break partway along the chain, everything after that point will fail. So what this looks like is some kind of a communications error that is happening around this area, but the position at which it happens varies depending on the level of illumination, and that is bizarre. Okay, so let's see what suggestions people have got. Oh, I just saw Andy sent me a message. What sort of diagnosis tools are you going to start with? Measuring voltage and current or signal, e.g. logic analyzer on the RGB LED data in, data out. I want to stick a scope on this. Now, part of this is going to be poking around and learning about how these LEDs work as well, because it's not just a matter of debugging this problem, which is interesting anyway. One thing that I have never done is stick an oscilloscope on the data line for WS2812B LEDs. I've used them many times, I've built them into things, but I've never just, looked at the data as it goes through. So let's stick a scope on it and see what happens. Yeah, as Johnny says, the bizarre part is that it's only at lower power. Now, okay. What I really want is to have more of my lab instruments wired up so I can include them on the live stream. Unfortunately, you can't see a lot of the stuff that I can see, but right now, okay, I'm running this off a lab power supply, which is reporting to me that it's pulling around, well, it's jumping around between about 550 milliamps and about 700 milliamps at 5 volts. Because what I've done is bypass the voltage regulators and I'm feeding just direct 5 volts straight in on the power rail for all of this. Now, if I turn the brightness up, let's just click halfway. Current consumption has gone up to, well, this is actually really interesting. The current consumption is now 1.69 amps, but it is rock solid. Like, it's fluctuating down in the milliamp region, hardly changing at all. So now that the flickering has gone away, the current consumption is stable to within like less than 1%. There's less than 1% variation in what it's pulling. But if I drop it down to this point, turn the brightness down, now it is jumping around between around 500 and now about 700 milliamps I just saw. So it's jumping around by like 30 or 40%. So the current consumption is lower, but because these are flickering on and off, it's varying dramatically from moment to moment. All right. Yes, stable because it's not flashing. Yeah. Alrighty. Now, we're showing a few live stream back. Yep. So, Austin's, I think Jacob Johnson asked a question. I missed the question, but I saw Austin's response. Sorry, I can't see the question. Yeah, so Austin said it has ground plane and VCC plane for the PCB. The PCB design was shown a few live stream back. Peter, morning! I would have come to your thing yesterday, but there's a lot of water between you and me. I hope you had fun. I saw some of the pictures that you posted. So let's pull this thing back out. Oh, and the other thing is that previous debugging sessions we're done with this. Like, I've pulled this up on a live stream before, but up until yesterday, this was all glued together. And so the only access I've had is to the back of the PCBs, and none of the data lines are on the back of the PCB. And in preparation for this live stream, what I did was remove a whole lot of the glue and pop it out of the frame. Now, if we lift this, let's see if I can get it out. It's a tight fit, but come on. Maybe get it out from one end instead of from one side. There we go. So I'll put that frame back out of the way now that you've seen that. Now you can see the individual LEDs. So yeah, all of the debugging that we've done before has been purely from the back, and you really can't get to anything. So there are all these little wires in here, and there are power connections on the back, but you can't really see anything much else. Data from the D1 Mini goes into the start of the chain, which begins somewhere up around here. I can't remember which one is the very first LED. We could pull the schematics out again and have a look. So from memory, the LED chain sort of wanders down, follows the direction of the letters. And so one thing, there are a couple of things we could do here for diagnosis. We could isolate sections. Now that we've got access to the front of the PCB, we could do things like isolate the data link that follows over from each of the PCBs to the next PCB. We could inject data directly here and run this PCB in isolation without any of the rest of it, and see if we can notice anything interesting. I should take the wedding ring off just in case I was just dragging my hand across the PCB and I thought, that's not such a good idea. Now, one thing that's interesting is that right now this sign is all illuminated red, and I'm just looking at the preview on the screen here. The camera's not really picking that up at all. All you're seeing is the flashing happening over here, but this is actually all illuminated. It's just the way the camera picks it up. If I move my hand over it, look, you can see there's sort of like an orange color coming through between my fingers, but it's only showing up where I move my hand. You can see the reflection on the edge of my fingers. But just looking at this directly, that whole sign is orange all across there. Okay, so because I'm curious, I want to see the data. I'm just going to connect into the data line somewhere back up here, like early on in the chain. I want to see what WS2812B data looks like. Now, somewhere around, oh yeah. Now, I've got an oscilloscope on the shelf just over my bench, but you wouldn't be able to see it. So I've been thinking about this a lot recently. I really want to do more stuff live, as in technical stuff live, not just talking about things, but You know, it's fun to mess around on the bench and get gear out and see what we can learn. Like that. And, sorry, my thought process derailed there for a moment. And to really do that usefully, I need to be able to show things like the live oscilloscope output and even multimeter and various other things like that. So I've been thinking more about how I can link that up. Unfortunately, the scope I've got doesn't have HDMI out, doesn't even have VGA out, so I can't capture its screen and then pull it into OBS. So I'm doing an alternative. This is like a mobile oscilloscope. This one's mainly used for things like automotive work. It's battery powered. But the good thing is I can just chuck it on the bench and you can see the screen through the overhead camera. So maybe we can use that to see what's going on. All right, but first, all right, I need some connections onto this board. And earlier, give me desktop please, I pulled up this because I can never remember the pin out on these LEDs. All right, so the little notch is at ground, and then it doesn't really matter if we're measuring off data out or data in because it's the same thing, kind of. It just links in a chain. So I'm gonna try tapping into, turn this upside down. I'm gonna try tapping into an LED here somewhere. Doesn't really matter where. So I could use, which pin? So ground and VCC are opposite. And there's a likely candidate. Let's head to here. One interesting thing now that I've got this under the microscope is you can see, let's zoom right in so we can see. I'm going to see if I can get some better focus on here. What you can see here is the artifacts of reflow soldering. Just move it up here. Try to get you some better focus. In fact, let's zoom it way in, as much as this microscope will do with this particular lens combination. Because what you can see are all the little balls in the solder paste. Brightness, a bit more brightness. There we go. So what you can see is the end result of the solder paste. So if this was hand soldered with just wire solder, you wouldn't see that effect. And this is interesting because I actually thought that James had hand soldered every single one of these, with a soldering iron and wire solder, but it looks like it was done with reflow. And where is that? Got to try to find where the microscope is focused. Which LED is it? It's too zoomed in. There. Where's the pointer? I can't find the pointer. Oh, there it is. Okay, so yeah, you can see around here there is all of this residue around the joint. That is because the solder paste consists of lots and lots of little balls which are all in a carrier sort of solution. I'm just scraping it away a bit there. Let's see what we can see. And so as it reflows in the oven, sometimes the carrier can sort of, well, it boils away, but it can also spread and smoosh out, and then you end up with a bit of residue like that. So yeah, looks like James did this in a reflow oven. Now, brightness is way too much with that magnification reduced. So I want to make a connection to which pin? Well, basically that one that is centered on the Grab me some solder. Yeah, the one that's centered on the in the field of view right now. So just going to put a touch of fresh solder in there and get a wire, a jumper wire. What can I use? Better find myself a little offcut of wire and solder that on so that I can attach the multimeter or the oscilloscope probe to it. Now, when I'm doing things like this, I wish I had some kind of audio feedback so that I could listen to you all talking, but I don't. Okay, so that should be a good place to tap off data. Now, we need a ground connection. Where's a ground connection? Should be plenty of them. Where? 5-volt ground. Oh, there's one over there. Okay, that'll do. I think, if they are close enough together. Yep. This one over here will do. You can't see it from there, but I'll get a ground connection on for the scope. Okay. So now we've got ground connection here, we've got a data connection here. Need to get some power back under there as well so I can turn this on. Doing this debugging live is kind of weird because I feel the need to talk continuously. It's like the old DJ thing of dead air is deadly. You never want there to be silence on the radio. So, but when I'm doing this sort of diagnostic work, I'm not. Oh. Yeah, it's easier if I don't have to talk continuously. I suppose the best thing to do is just try to talk through whatever process I'm going through so you can follow along and see how wrong I am. Scope on. Handtech. Hello, Handtech. Is this going to reach? Just. I've got no idea what the settings are on the scope. Let's turn on the sign and start. What have we got? So Vmax is 5 volts, Vmin 3.43. That's kind of surprising. I would have thought that a low would have been below 3.3. Maybe that's a timescale related thing. So volts. Let's increase our scale a bit. So we've got 2 volt scale. And let's just start playing around with the, which way are we going? The weird thing is I'm actually having trouble reading this because I've got so much glare coming off this. On screen to you, this doesn't look particularly bright. To me, it's like looking into the sun. So, where are we going? Time division. Where is the time division setting on this thing? Time, 50 milliseconds. Okay. No, we're going to go the other way. 20 milliseconds. We want to make it much shorter. I want to see those data pulses. Come on. No, surely we should be seeing it by now. Where's trigger? Trigger is set way up there. Let's bring it down. We're not seeing any variation in this. So one thing I don't know is whether I've never actually looked at the protocol either. So I don't even know if it's sending any data at any time except when, yeah, at any time except when it changes. It may be that it only ever sends data at the time that it is updating. So let's go back to here and get some kind of an animation going. What can we do? Solid, Android, it doesn't even matter what the animation is as long as it's something. Well, yeah, that'll do. So, what have we got? Oh, back to overhead. So at least now we've got data flowing through the chain. So let's see what we can find. See if we can get some data visible. No, surely not. How have we not seen anything? On this, let's just hit the auto button and see what this thing does. Turn off, where's channel 2? Channel 2, turn it off. Vmax, this is not making any sense. So we're getting Vmax in here of 11 something volts. Minimum is jumping around all over the place. Am I even connected to the right place? What am I looking at here? We've got ground there, ground to there. We've got that, which should be to a data pin. And I am not seeing anything useful. Got to increase the time scale again. This is very strange. I was expecting that I was just going to see like a series of, like that time scale is way wrong. It's out in the milliseconds region, many milliseconds region. Why can't I see it? All right, I'm going to go for, I'm going to get this out of the way for now. And grab a different probe because I'm not sure if this is me just not knowing how to, whoa. Not knowing how to drive the scope or what is going on. So, going to see if I can see some data packets appearing here. Ooh, and I can. On the Rigol scope, gotta get the trigger settings. It's all over the place. Come on, get the trigger. Gotta see. This is really weird. It's much less predictable and stable than I would have expected. And right now this is the most boring thing in the world to be watching because it's just me twiddling knobs on a scope that you can't even see. Come on, trigger level, trigger mode is auto, yes. But this voltage is wandering around all over the place. All right, now what have we got here? So 2 millisecond time scale. And we're on 500 millivolts per division. So let's see if we can get anything that's visible to you on the screen instead of just to me by switching back to this other scope. You can see where that is, and let's move this down. Volts per division. No, 500 millivolts. Get it back down here. Oh, it's getting closer to, no, wrong way. No, that way. Come on. Got to get it down onto the screen. All right. So, it doesn't want to go any further. Come on. All right, so what you can see here, I'll see if I can get the, where's the trigger level? There. See, I'm not changing anything there, and the voltage is actually wandering up. Vmax 3.98. This behavior is just strange. I was seeing this on the Microscopic as well. But what you can just barely see, now if I just let it sit there and wander down again, I think maybe what I need to do is I'm going to change to a pattern that has all of them illuminated. So what this seems to be pointing to me is a power issue. See, I'm not anywhere near it at the moment, and what you can see is the average voltage is, now it's rising, and then slowly, in a moment, it's going to start coming back down again. So it goes down, 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 down. Really weird. Aaron says you're not on a data line. That would explain it. That would definitely explain it. And I think Aaron is right. That would definitely explain it. So, thanks Aaron. So we've got ground and VCC. Yes, what we're actually looking at here is noise on the main power supply line. And you can see it slowly wandering up and down. So this is the, yeah. You are absolutely right. That is, okay, power off and disconnect that, and back to here. So I was so distracted talking about the solder artifacts on this that I stopped paying attention to what I was connecting to. So what I've connected to is the pin that is diagonally opposite the little notch on the LED, and that pin is VCC. So let's see if this changes everything, which I sincerely hope it does. Okay. Got some data happening there. Get power back on there. Oh, nice. That is, like, that's a packet of data. Let's bring that back in. No, not 10 volts, and I want to reset that. In fact, let's just hit that auto button again and then get rid of channel 2. And volts, what are we at? 20 volts? No, we want to be at 2 volts a division. Yeah, that'll do. Bring that down a bit. Where's the trigger? Bring it back up to there. Oh, here we go. Let's try. That is, yep. And then if we change the time scale, that's better. Although I'm surprised by the volts per division that I'm, look at this, Vmax. It claims to be jumping up around 30 volts, but anyway. Okay, now we're getting somewhere, I think. So we can actually see what looks like a data packet. And let's zoom in on it a bit. And you can see that it's, where are we? I don't even, oh, run stop, there it is. Where's the trigger? Set trigger mode to... am I sticking my head in? It feels like I'm sticking my head under the camera trying to see this. No. Oh well, anyway. What you can see there is it looks like there are a couple of different widths of pulse. You can see there are typical narrow pulses, and then there are other pulses that seem to be twice as wide that pop up occasionally. So if we could try capturing a bunch of it, but to kind of save, recall. I've only ever used this oscilloscope a few times, so I'm trying to figure out how it does stuff. Does it capture? I have no idea. I don't know if this has got memory or not. Let's just move this across and see if we can see the whole packet. No. Come on, move it back. No, hang on. I'm going to switch back to the other scope for a moment. The one that I do actually have some idea of how to drive. And see what we can capture, if anything. Anyway, not the most riveting viewing. I'm sorry. Where's my trigger? There it is. Yeah, not very useful. All right, I'm going to also something else interesting I just noticed. Hang on, did I change the... Yes, I did. I'm just saying random words at the moment. What's going through my head and what is coming out of my mouth are kind of unrelated and not making a lot of sense. Now, if I turn this around, there are a couple of things here. Firstly, you can probably see that the last 3 LEDs here in the chain are not working. And that could be because one of these LEDs has failed. It could be a bad connection there somewhere. Or it could be as simple as I miscalculated the number of LEDs in the when I was looking at it. So this has been configured with, let's see, where is config, LED preferences, 385. Let's just change this to 388 and save it and see if that makes any difference. Has it? It has. I thought there was a fault with the last 3 LEDs. Now, just just out of curiosity, so 388, let's make that 378. Save it, and let's see if the last few LEDs turn off. What? I've just lost my desktop capture. OBS just freaked out. No, maybe that, what? See, this is the thing, is the more I mess around with this, the more confused I get, because things seem to be, all right, I'm going to turn the power off, turn it back on. Okay, that's better. So now we're missing the last 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are missing the last 10 LEDs. Good. So now we know that there are 388 LEDs on here. I'll save that. And they turn back on. Hooray! Actually, this is kind of interesting. So if I go back to LED preferences. Now, this is what had me confused for a moment just a second ago. We've got 388 LEDs configured, so it is sending data for 388 LEDs. Now, if I change that to 378 LEDs and save it, at first I thought, oh, those 10 LEDs are just going to turn off. But no, they don't, because they are still going to keep displaying whatever the last data was that was sent to them. So if now that I've got 378 selected instead of 388, if I change to say green, you can see that it's updated the first LEDs up until that point. And I can change that to blue. And those last 10 LEDs have not changed color because they still have power applied to them. And they are just going to keep displaying whatever was the last command that they received. So now if I go back into config, LED preferences, set it to 388 and save. It will then write out data for 388 and it updates the last ones. So that explains why they didn't turn off when I decreased the number of LEDs in the config. Alright, so that's a problem that doesn't exist. I thought there was a problem with the last 3 LEDs and it was just that I had messed up. So we've got 388 LEDs. GRB. Oh, Andy just said, do I have a Salier logic analyzer? Yes, I do. Oh, and Aaron said, isn't it acting stable? Now is brightness turned up at the moment? Yeah, it is turned up. Kind of. Hang on. What's it set to? It is set to a bit over the midpoint. Now part of this seems to be the interaction with the diffuser. So if I drop, so I've got the brightness turned right down now. And you can see that it's flickering in that last part. This is all illuminated blue right now, which you can't even see. This is so weird the way the camera does that. So I put my fingers over it and you can see the blue glow between the fingers. Just looking at this, all of this looks blue to me. And this is flashing red and other colors. Now, if I put the diffuser over this, you can see it becomes much more fuzzy. There it's more distinct. So the lazy option here, I'm going to turn this brightness up. See, so on camera, that level of brightness looks fine and it's quite distinct. If I put the diffuser over it, all of a sudden it just becomes a blur. And that, something just messed up then. That is why I want to turn the brightness down to here, like down like this, to make the letters more distinct. Now, at the moment, the distance between the diffuser and the LEDs is bigger than it should be, because this is just sitting on top of it. If it was down closer, it wouldn't be as blurred as that. But the lazy way to solve this problem is to turn up the brightness and remove the diffuser, or use a diffuser that is not as granular. Now, if we look at this, you can see that this consists of a whole lot of dimples that are quite large. I'm going to try something different. And yes, I know this is not really solving the problem. This is just, where can I find a bit of paper that doesn't have something confidential written on it? Oh look, a credit report. So if I chuck that over it, it acts as a diffuser to some extent. Not enough though, it needs to be a bit more. What else can I use? I've got some core flute around, but the problem is that's got texture in it. How about just a few more sheets of paper? And we'll see what that looks like. Yes, I'm probably revealing stuff there I shouldn't. These documents are actually related to identity theft. That's a whole other story. My identity has been stolen. Yeah, it's not really very satisfying having it like that, showing the dots. It's okay, but I think the diffuser does need to do a little bit more than that paper does. Yeah. Okay. So. What I'm tempted to do is just try sticking a couple of capacitors down around here. Although there was a, I don't know if that's going to be useful, but there was a very interesting question on Twitter last night, which is, what is the total capacitance of the PCBs? Because these are basically poured with ground plane on one side, 5 volts on the other. So that it's just 2 big plates. And that PCB essentially is going to be a capacitor. The value will be very low, obviously. It's a very small amount of capacitance, but still, there'll be something. And the question was, can you measure the capacitance? And I don't think we'll be able to get any useful measurement out of it because because it's got all these LEDs connected across the between the positive and negative. So that would, if each of these is going to be it's going to be like a little current sink. So if I connect a multimeter across this to try to measure the capacitance, it's going to read very high because of all of those LEDs. Oh, Andy said, notice how the last 20 or so RGB LEDs have a slightly different intensity of red. Let's see that. I don't notice that. I wonder if that is to do with like camera angle or where I had it. I can't see any. Just going to change to a different color. Let's go for blue. On camera they all look the same to me. To my eyes they all look the same. Don't think there's variation in intensity there. Yeah, so Ray Ralston said, last time you looked at this, the power to each section was powered by a DC to DC converter. It looked like all the positive connections were connected together. Yes, so that is something that is probably, I would classify that as being slightly dodgy. So these are switch mode regulators, and they're essentially wired in parallel. Now which way around is that? From that to that? Okay, so the wires on here are the input side, and then there are outputs going to different things. These boards have a common supply and ground all the way through them, and then there were multiple modules that were just feeding it in at different points on the PCB. So you can see here these three modules. There was another one up here, and there are different power injection points along the PCB, but effectively what that does is it takes all of these modules and it connects them directly in parallel with all of their output, negative side connected together and their output positive sides connected together. With linear regulators, that is generally okay. With switch mode regulators, it can cause them to have problems. So that was one of the reasons that I wanted to try isolating all of these regulators and just feed power in like this. So what I've got at the moment is just the positives jumpered together and the negatives jumpered together. Now, one thing I'm curious to do is try supplying the data directly to this. So I could take a jumper from there and take it to the data pin on here. What is JP7? I wonder if that's data out. I suspect it is, so that can be daisy chained further. I'd have to look up the schematic to work it out. Well, I need to catch up on some chat. I totally ignored the chat last week, and this week I should try. Oh, James just said, good luck getting that diffuser out though. Yeah, it is well and truly glued in. All right. Now, what have I missed? And sorry, I'm just getting myself organized here. Okay, awesome. So Andy has been feeding me things in the background and I didn't even have that window open. All right, okay, so there's an observation here. Andy said, with that Android pattern, it's really interesting to see that the flickering only occurs when the flickering RGB LEDs are being updated. Oh. And there was also a suggestion from Some Call It Fun, which is maybe a bad pixel in the last S. Yeah, that was actually my original thought. So when I first turned it down and I saw it start flickering at the end, I thought there's an LED somewhere around here that is dodgy. So it'll just maybe be a matter of replacing the LED and it would all be fixed. But the weird thing is that the position changes. And that is really what's throwing me for a loop with this and making me inclined to think that it is power supply related. So I'm going to just pull up the design files for this, because the thing is that the way these RGB LEDs are supposed to work is that they have internal buffers. So each one of them has an input and it's got a line driver on its output. Now I've got to find where on earth did I put the design files for this. I grabbed them off James's GitHub and stuck them somewhere. I think even searching for this is probably a lost cause. I'm not going to find it. Come on. Yeah, I think it would be too boring while I sit here and dig through. Hang on. Oh, maybe in the archive directory, which in itself has hundreds of things in it. Oh, here we go. SuperHouse logo PCBs. All right, I'm going to go for the house PCB and pull it up on screen in just a second. All right, desktop, here we go. So this is the house PCB. And if we look at the schematic for it, it is basically a chain. This is classic WS2812. So we've got data in, you can see signal in, this is where it comes in from the D1 Mini. So signal in comes in here, it goes into data in on the first LED, which has power and ground connected, and then data out, which comes to data in on the next LED. And okay, oh, there are a few dangling nets on there. So what is supposed to happen? The way these things work, if you feed a signal into the input of this first LED, internally what it does is read the data, and then the control chip that's inside it then drives the output. So whatever comes in on this output should be a perfectly cleaned up signal. So if you've got something bad happening on the input side here, as long as this LED can read it, you'll get a nice clean output coming out on the output signal. So, so that is why I find it weird that this is moving. And if we go to so I'll turn down brightness, go back to overhead. Hang on, do I have a desktop thing here? No, I don't. Yes, I do. Sorry, I can turn that on. All right. Sorry, I was just messing around with OBS config so that you can see the interface and you can also see the sign. Now, Andy made the comment that it was interesting to see that it was only happening when the letters were updating. Look, you can see that it's gone through the symbol, it's getting to H, and now it's moving on through the word house. We'll just let it run through, does its weird flickering thing there, gets to the end, and goes back. I'm not sure if that's a clue, because just watching that behavior. So it is flickering even as it's tailing off. Yeah, not sure. All right. Sorry, I'm going to try to catch up on some of these messages, because there are probably a whole bunch of good suggestions for things to investigate. Yeah, so that's right. So that was about Some Call It Fun's comment about a bad pixel in the last S. Yeah, so my point about the position of the flicker changing indicates that I don't think it's one particular LED that is bad. Now if I go to, let's just pick a different thing. My phone is buzzing. What's going on here? Yeah. Not related to the live stream. That's okay. I am so all over the place today. My brain is just not engaged. All right, so what was I doing? Blends, that's right. Okay, so what is that pattern meant to be? I don't know. It's like it's a, oh, blends between two colors. Let's pick a different color. I think what this pattern is meant to do Oh, so that's color 1. Oh, okay. Let's make color 2 blue. Color 3 will make it red. So what we've got is, it's a bit hard to make out, but these are sort of slowly transitioning between different colors. And then from around this point, it is starting to flicker. But you can see that the location of the flicker is changing. Right there. Now, the next thing that I think I'm going to do is I'm just going to grab a couple of capacitors and solder them across here to see what happens. But first I'm going to get through some of these comments. Yeah. And Peter says, what's interesting is the flashing is a repeatable sequence, happens at the same time every time. And Mako said, didn't anyone else notice the disturbances and flickering are very steady on off? I hadn't even thought about that. So the characteristic of the that is an interesting observation. What it looks like, it's probably a little bit hard to tell on the camera because of, there might be a rolling shutter sort of effect on the camera. So it looks like the flickering is moving across it. Just looking at this, what it looks like to me is that all of them are flickering on and off simultaneously. So that could be a bit of an optical illusion, I'm not sure. It's very hard to tell because it's happening so quickly. But it does look to me like they are all turning on and off. It's like they're doing their pattern, but being modulated, as in like power being turned on and off. And Peter Kirchhoff said, as soon as the H on the house starts to turn off, the flashing starts. Let's try what's blink rainbow? Let's try a different pattern. There it's almost stable and then it changes color. Yeah, it seems to be just around here somewhere, halfway through the H. But sometimes it makes it further back. And sometimes the flickering starts down here. Then it just started there. Mako said, what board is inside? An A266? Yeah, it's got a Wemos D1 Mini, which is an ESP A266. Aaron said caps would be the way forward, but that's a lot of caps needed. Yes, it is. Andy asked if I have a Salier logic analyzer. Yeah, so that's something else that we could dig out as well. And rather than the oscilloscope, use a logic analyzer. And I could then pull that up on the screen. I think I've got this, it's a while since I've used it, but I think I've got the software installed on here. And Stephen W said, can you monitor VCC on the end section LEDs? And look at the S words doing the same. Look at VCC on the end section LEDs. Yeah, so that could be worth checking out as well. So Henrik said, just put the flicker mode and look at the S word. It's doing the same pattern every time at the end of the S. All right, flicker. Let's try, what have we got? I need to find an effect that really helps us to see this. So I've got, this is kind of an interesting observation. All right, so we've got, right now it is in blink, which means that it is switching between several different colors. So green, that's blue, it's back to green, and then blue. But you can see when it's on the blue mode, the flickering almost goes away. And then when it switches to green mode, the flickering comes on. So flickering, no flickering. Flickering, no flickering. Or just a tiny little bit of flickering here. Oh, last 20. I misread that comment earlier. So Andy said, notice how the last 20 or so RGB LEDs have a slightly different intensity of red. I misread that comment earlier, and I thought it was that the first 20 had a different intensity of red. Let's go red, 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 red. Okay, so this is just solid. This is supposed to be solid red right now. And what you can see is that it is solid red all through here. And then some around here go green. But it's at a different point each time. Yep, oh, Ray had a comment. I think I've already addressed that one. Paper diffuser? Oh, so Andy said, when you had a paper diffuser on them, perhaps getting a slightly different data rate. So this was different RGB LED intensity was clearly visible. Can you remove the house sign middle LED plate and output jumper in and test that? Yeah, so changing the... Alright. Yeah, I've got a few things that I want to try, but I'm going to try to read through these comments first. I've got some ideas about testing different power supply configurations and things. So... and Henrik also said, can you try the Arduino Fast LED Library demo reel with the LEDs and test that? Then you can see if it flickers as well. Then use another Arduino if you don't want to delete the settings now. Yeah, so that was something else that I was thinking of doing. I need a list of all the things I want to try. And Andy said, yes, and the point of flickering is exactly at the point at which the RGB LED value is being changed. Looks like data corruption, said Ray. William Giles said, try the loading effect and set the intensity to something low like 10. What is loading effect? I'm not very familiar with... Oh, there it is. I'm not very familiar with WLED. So I've just selected loading as the effect. And should I need to do anything else, or is that it? Does it just do it when I click it? So I've clicked the loading effect. Okay, so the loading effect runs along the string. Move that down there so you can see it. So it's zipping along like a worm. Actually, I think there's a worm pattern as well, which is kind of useful for this type of debugging. No? What, maybe? Ooh, interesting. You can see some weird flickering happening just around here. That colour, that LED, these LEDs are a slightly different colour to these other ones. Goes around there and then up to there. And you can see that this LED is flickering, that one is not. So this is where the chain comes in. It comes in there, goes around, ends there. That is the output that goes to the next board. Let's see where the next one comes in. There, okay. So that LED is being influenced or is influencing what follows on from it. All right, I want to start disconnecting things and moving things around, but I've got to read these comments. All right, create a segment that just operates house and see if the flickering happens. Ooh, yes, okay. Create a segment. Kennewell VCC on the house board before and after adding caps. Peter said take some slow-mo video on your phone. Oh, cool. That's an interesting idea. I wonder if that would work. Do I have slow-mo on this phone? More. Slow motion. All right. Let's see if I can capture anything useful in slow motion mode. And then play it back. Yeah, it might be possible to get something interesting out of that. Transferring this so you can see it, it's going to be hard. You're not really going to be able to see this. But you can distinctly see the flickering. So this is running in slow-mo mode at the moment. Yes, okay. All right, there are still more comments that I haven't got to, but I'm going to get back to starting to hack on it. So Aaron's suggestion was create a segment 238 to 388. Yeah, so this is throwing back to that earlier comment a moment ago. Add segment. So we've got segment 0 goes from 0 to 388. And I don't know how the segments work in this, but let's just add a segment. So I don't know if I need to change this to be less than 388. Maybe we can just disable segment 0. So let's see, start LED, and we'll go from, what was Aaron suggesting, 238 to 388. So that's 150 LEDs. Yes. Now I'm going to turn off segment 0, turn on segment 1. I've got no idea what effect that is going to have on anything, but let's now, do I need to power cycle it? How do we use these segments? Segments. Are there any patterns that are specific to the segments? Down in the S section? No. All right, now that I've changed that, I'm just going to power cycle this. And see what happens. Okay, so it's come on all solid red. And then what? There is no more flickering. What? What is going on here? All right, loading UI. Oh, the brightness is turned up. Let's turn the brightness back down again. Yeah, now the flickering is back. It didn't record the segment. Did I need to save that? How? All right, what's going on? All right, I'm going to do this again. Add segment. Start from 238 to 388. Yes. Turn that segment on, turn that segment off. How do I now save that segment? The fact that I've changed this in here doesn't seem to have done anything. So I'm just going to go into config and then back again and see if it's lost it. No, it's still there. But when I power cycled it, it lost it. Alrighty. Okay, so intermittent text said just edit segment 0 to a part and then segment 1 to a part. Alright, let's do that. I'm going to change this, instead of going to 388, because that could be screwing it up, I'm going to take it to 237. 237. All right, so we now have segment 0, which is 0 to 237, and segment 1, which is 238 to 388. I have no idea what grouping or any of these other settings do. So, and what I'm changing here doesn't seem to be having any effect. I've got no idea how to use segments. All right, let's try. This is the point at which I would start reading documentation, but that's not particularly interesting to watch. So what I want to do is turn off segment 0 and turn on segment 1. How do we do this? Okay, so intermittent text says set the tick mark on the segment you want to change color or effect for. Ah, okay, that actually makes sense. I'm going to turn this one off. So I'm going to set, let's see if this works. I'm going to bring this up to larger desktop so you can see what's going on here. All right, so I've got one segment, 0 to 237, one segment, 238 to 388. If I now set the brightness to 0, it affects all of it, not just segment 1. I'll turn the brightness up a little. Solid, I want it to be off. So I'm going to set, hey, this is actually kind of working. You can't see it, I'll have to switch camera views. All right, so I've got the first segment selected and I've set it to 0. So now what you can see is that segment is turned off. And the second segment, so what I'm going to do now is deselect segment 0, select segment 1, and make it, say, red. And turn the saturation way up. I think that LED count may not be correct. I don't think it's 237 because there are another 4. I'm going to edit that to make that 233. And start this one at 234 and come back to the first segment, just change its settings, come back to the second segment, change its settings so that it writes it out. Now you can what you can see here is that these first 4 LEDs are not illuminating in the H section. Still not illuminating. Oh, hang on. This has just changed back. 230. Oh, it's because I didn't tick. All right, I've got to click the tick to apply it. Maybe now it'll fix it. Yeah, that's better. Okay, so now the boundary is correct. So LED 233 is the segment. Now in messing around with this user interface, I have totally overlooked the fact that we've already proven something, which is that the flickering continues even with all the other LEDs turned off. And according to my bench power supply, it's currently pulling around an amp-ish, give or take. Let's try, let's add another segment. I have a feeling that this may have been how James had it set up in the first place with segments. So I'm going to add segment 2. I've changed that to be 234 to 388. And where does the first one end? Let's just take a guess. I'm going to make that 150, and I'm going to start this at 151, and I'm going to take this one back to 233 and apply that. And oh, it was close. So I need 1, 2, 3, 6, 7, 8, 9, 10. So stop LED, I'm going to make 160 and start LED 161. So just to explain what I'm doing here, I'm making 3 segments so that the 3 boards each have their own segment that we can control independently. And 150, 160? 159, I think, is where that one needs to start. And that one, 160. Nope, went too far. Oh, 161, 160. Sorry, I'm just eyeballing it and making adjustments as I go. I'll show you in just a second. So I need one more in that segment. So that's got to be 234. And that's 235. Is that it? No, there is one LED. Maybe I'm misunderstanding how this config works, because it looks like there's a gap between these segments. I'm going to change that back to 234 and this to 233. 160, 161. All right, so what I'm going to do is make segment 1 red. And then I'm going to select segment 0. Then segment 1, I'm going to make green. And then segment 3, I'm going to make blue. Okay. Now we have control independently over the different segments, but there is an interesting thing here. That top LED is not turned on. This LED is not turned on. And that one seems okay. So there is something going on with the transition between those 2 segments. Okay. Let's have a look back at this config again. So we've got 0 to 160, 161 to 233, 234. Yes. This is slightly baffling me because I've got start LED. Oh, Johnny's paying me to add caps. Yes. I do want to do that. Oh, okay. GUI gotcha. Some Call It Fun said, start and end must match off by 1. Yeah. That is what I was just trying to figure out, because we've got that little gap at the end there. So the stop LED on that one should match the start LED on that one. But then why don't I have a gap in here? Oh, okay. Let's just make this 161, and we'll make this one 234, and spacing. There was a spacing number in there. James is also paying me to add caps. Yes. All right. Yes, that solves it. Okay, so that GUI, I don't like that. What it should be is the number of the first and the last LED in the... Look at this. So segment 0 is from 0 to 161. Segment 1 is from 161 to 234. So the first LED that is defined is LED 0, because we start counting from 0. But then stop LED is 161. So why does the final one included in that segment have the same number as the first one included in this segment? So this must actually be the LED after the last one that you want to control. That's really dumb. Alright, but it just seems to be the way it is. So this is the end result of what we've got so far. We now have control over all 4 of them. Now I'm going to go to, what have I got selected? Segment 2, and I'm going to turn the brightness down. See if we can get some flicker happening. There we go, now we've got some flicker happening. And what I'll do now is turn, this is kind of useful for debugging because it means we can isolate things. So since I'm being paid to add caps, I should do that. Now what is the cap value that we're meant to add? And doing this with surface mount caps is going to be a pain, unless there are particular places where there are no, unless I diagonally linked across. I'm just looking for places where I could add caps using surface mount parts instead of using through hole. Because what I could do is grab out a box of caps. What have I got in here? And what should I be putting on? Is it 1 microfarad? What is the usual thing that you put on a WS2812? Let's have a look. Choosing a capacitor. Okay. And James said, what happens if you only inject into the house PCB? Yeah, so messing around with that sort of thing was where I was going to get to. I'm trying to do things without hacking it too much. Alright. Soldering iron still on, yes. So that is actually a reasonably simple change. I can test that without too much of a hassle. Okay, what I'm going to do is take the data output from the D1 Mini and inject it straight into this, which, can I get to the back of that? Oh, getting to the, isolating that is going to be tricky. Where is the data pin coming from? All right, I'm going to have to do some digging around in Eagle again, because I think I'm going to have to cut a track. I can't easily isolate the link. So the data output from this board goes to the input on this board, but it happens at these little jumpers up here. There's obviously a bit of jumper wire or something soldered on the other side of the PCBs. But if you look at this, there is wood on it and this is all glued on, so I can't get easily to the back of that. That is where I need to inject, I think. Let's find out. House board. Yes. So that is where I need to inject it. Hang on, I should be able to just cut it on the top of the... Oh, solution is so obvious. Okay, let's do this. Soldering iron is hot, so we can get straight into it. And we'll do a little bit of PCB surgery. All right, so I'm going to do it in a reversible way, obviously, because I want to be able to set this back to how it was. Get some focus. Get that on there. And that track that you can see running vertically straight up the middle of the PCB, that is the data input pin to the house board that goes to the first LED. So if we do a little bit of rocket surgery on this, we should be able to cut this track and isolate it from the rest. So now if we bring this back over here, back to overhead, turn power back on, we got nothing on that last board because the data is stopping right there. So let's turn that back off again. And the data from the D1 Mini comes out of here. It's pin D2, it's that yellow wire. So I'm going to remove that. Now, one of the other interesting little things about this is that the D1 Mini is running at 3.3 volts and WS2812s require 5 volt logic on the input. And so technically this is running them out of spec. But I'm totally ignoring that right now. Now, a bit of wire, that'll do. Where have I got to get it to? About there. And this is possibly going to make things worse because not only is the D1 Mini driving them out of spec, it's driving the input of the LEDs with only a 3.3 volt logic level, but now it's going to be doing it over a long wire. So sometimes in that situation you get away with it when it's out of spec if the connection from the microcontroller is directly to the LED, and then then it works all right. But if you've got a long wire, a bit of resistance in it, the signal can get a bit of noise on it, it all gets a bit marginal, then it can be a problem. So where is this thing going? It is going to the top left pin. There we go. That one right there. So that pin is the data in on the first LED in-house. Okay, back to here. Now, power. And we have a nice constant house, but it's being driven as if it's the first segment. So I've got to switch back to WLED. Where are we? Segment 0. Hang on. See this? It's lost all the segments that I defined before. I don't get WLED. That's weird. Alright. Turning it down. Turning it down. Whoa. We have 0 flickering. I'm going to turn it down even more. Well, it's working with no flickering at all. Totally smooth. Right, that means it's time for a drink. Now, what we can do, let's do something a bit strange. I'm going to loop the output of that back to the input of the word super, because then what we can do, oh, check that out. See this LED turned on? That's because I touched, look at this, I'm touching the data line just with my finger, and that was enough to spoof the LED into thinking that it had received a command of some kind. All right, so if we take the output now from down here, feed it all the way back into the input on the first thing, basically all we've done is change the order of the panels. So we've made this the input point, and then that as the as the second part of the chain, because what I want to find out is, by doing this, is whether having all of these LEDs illuminated is going to reintroduce power problems, possibly. At the moment, because we're only illuminating this section, we're not seeing all of the possible electrical noise that could be going on. Power supply is off, good. Before I start soldering stuff onto here. Alright, that was very considerate of James to include the data out pin on the final board, because that means we can loop this all the way back up to the input. There we go. Now power on. And it's back to high brightness because WLED does not seem to be able to save anything. What do you have to do to make WLED save its settings? Oh, check this out. Oh, hang on. We got some flickering. We got some flickering. And it is towards the end of the chain. Not much though. You can just see some weird things happening down around this section. So, to recap, what we've got now is the D1 Mini data is coming on this wire and going into this. So this is the start of the chain now. It goes through the word house. The output of that loops back around, comes all the way down here, and it goes back into the start of the word super. So the chain goes through super and then goes to the logo. So the logo is now the last part of the chain, which is where house previously was, like the end of the word house. And what you're seeing is some weird flickering sort of things going on there now. All right, some observations about this. This is not what I expected of a power problem, because we haven't changed in any way how the power is getting to these LEDs. It is still the top and the bottom of the PCB connected to all of the power and ground pins on all of these LEDs, and we're still running the same injection. So what I was expecting was that if this was a power problem, the flickering would still occur through these characters, even though they are now earlier in the chain, because the data is taking a different path, but the power supply situation is exactly the same as it was before. That hasn't changed at all. So that is interesting. Yeah, Ray said make at the start of the data chain to see if everything after it starts to flicker. Yeah. Yeah, we could try doing that. So Mako said, is it a power problem on the data line? Could be interference on the data line, possibly accentuated by lack of filter caps. Now, before I do much else, we could reconfigure this and change it so that this is now the start or whatever. What I want to try is just adding, how are we going to validate this though? We need something reproducible. What I was thinking of doing was just returning it to its original configuration and then adding, just a couple of caps somewhere around this region and see if that makes any difference to the problem. So yeah, what the hell, let's do that. I've got people in the chat paying me to add caps, so I should add caps. Okay, so I'll take that off there, take that off there. Now this is the data line coming from the D1 Mini. Now, even though it's kind of dodgy having it on a long wire for convenience, I'm just going to solder that onto the start of the chain. Then we have the brake that is up here now. So I'll fix that with a little bit more rocket surgery. Where is that? Get that on. There we go. So a little bit of scrapey and a little bit of jumpering, and that track will be repaired. So I'll just get rid of this very nice looking matte black solder mask. Tin a little bit onto there and onto there. Now I need myself a bit of, I had a short bit of wire, I must have thrown it out. Okay, time for another little bit of wire wrap wire. Here we go. And chop that off to make it a bit neater. So now we've got a bridge going across. Alright, so in theory now we should be back to the original configuration. Let's just power it up, see what happens. And back into WLED. Turn down the brightness. And there we go. So we're back to the original behavior of things starting to flicker crazily towards the end of the chain. All right, where's that big box of, there it is. My capacitation box. Let's just grab something. Now, they're not perfect for this sort of thing, but I think I'm going to have to just use some electrolytics. What have I got? Unfortunately, they're not ideal because the ESR on electrolytics is kind of high. But I can't really just bridge ceramics in there at the moment. So I don't think I've got any through-hole ceramics in the right sort of format. All right, so time for a little bit more bodgifying. Turn that off. And I'll try to make sure that I don't put these electrodes on backwards because they make big nasty noises when you do. So I'm going to have to pay attention to this. All right, so we discovered earlier that the notch at the LED is ground and the opposite one is VCC. So let's find an LED somewhere towards the start of the H. It's probably a good place to do it. And I can see an LED here where there's a joint that looks like it's not quite soldered. Yeah, wouldn't it be funny if that turned out to be the issue the whole time? Not funny. Not funny at all. So, I'm making a mess of it here. All right. Let's start by just putting a cap on one LED. Turn on the power, see what happens. Yeah, you can just barely see it. That's the end. There's an electrolytic right there across one of those. Now, obviously one electro is not going to, well, it shouldn't solve this problem. Hang on. Has it solved the problem? Seriously? Oh no, there is still some flickering if I turn it right down, but only just. Well, after all this, the one electrode seems to have solved the problem. All right, just to verify. Now, I'm going to do something a little bit dodgy here. All right, with this powered up, oh, you can see a little flicker just down towards the end there. But it's nothing like what it was before. Like before I had this was going all different colors here. It was going crazy. The level of illumination is turned right down now. And you can just occasionally see a little flicker. So I bet if I added another capacitor down here somewhere towards the end of the chain, even that would go away. All right, I am going to cut one lead on this capacitor and we'll see what happens. Look at that. Wow. Now I'm just going to hold the lead closed again. Oh. Yeah, you can see a little flicker there. But that is super distinct. All right, I'm going to turn that off. Solder this little lead that I cut. Solder it back together, and I'm seeing stars because I've been staring at these LEDs. I've got like white spots right in the center of the, if I look at things out of the corner of my eye, it's fine. But it's like I've got spots right in the center of my, my view. So I have to look at things slightly sideways to be able to see them. All right, so I've got another capacitor here, and I'm going to do the same thing again. We'll find a we will find a likely candidate further along the chain somewhere, down towards the end. And where should we attach it? Find one that's... Oh, this one looks like it's had some rework done on it. So I'm going to use that one as my candidate because it's already got extra little bits of solder on it. All right, so ground was that one, VCC is that one. So do a little bit of bendification on these leads. Get that one in there. That one in there. And then I've got to try to, well, I'll bend this capacitor up so it's vertical so that it's not obscuring the field of view. Yes, and all the people that have been shouting at me right from the start, put capacitors on it, are going to be 100% vindicated right now. That is with the illumination turned up. Now back into WLED. Now, quite apart from this, I am still confused about this whole WLED thing of why it won't save the settings that I'm changing. So that is turned down to a really low level of illumination now. You can barely see it on camera. I can see it, like I can see that each of these LEDs is turned on. Ooh, there was a little flicker just there. Maybe that's because I was sticking my hands on it. Every now and then I'm seeing a little flicker. Some LED changes color and then goes back to red again. But that is now with two capacitors on it. And you can see that that seems pretty much rock solid. Let's try some different colors. Blue. Oh, we got some flickering. Ah, the problem is not entirely solved. I think it is solved enough that we've demonstrated that it is a power problem. It's So with some more caps in place, I think we would be fine, even with different... intermittent text said, try the palette effect, solid FPS equals 4, effect FPS equals 42. Intermittent tech, you've obviously played with WLED a lot. Peter Kirkos suggested the cap is compensating for a bad LED. That may be the case. Now, so back to intermittent text suggestion. Palette effect, palette. Oh, come on. Palette effect, and then solid FPS equals 4, effect FPS equals 42. Where do I put that in? Are there particular configs that are specific to the selected pattern? Like if I go into config, it doesn't have anything that is specific to that pattern. So I don't know where the solid FPS, all that sort of stuff goes in. Do we put that into, is there like a console where we can type commands? I don't know. Oh, okay. Intermittent said, no need to put FPS in. That's just how it works internally. Solid gets less updates. Yeah, solid gives you the wrong impression. Test with an effect. Okay, well, we now have this palette effect going, and it seems to be nice and smooth. I'm going to turn the brightness back down again. Now you can see there is a little bit of flickering occasionally, just there. So most of the time, this is all nice and smooth. And then there is, sorry, I'm pausing here because I'm just seeing whether I can see an effect. What I'm noticing is these LEDs down this end, it's going to be very hard for you to see. Let's see if I can get some zoom happening. Zoom. And now, how can I isolate this so that you're not getting glare that's going to... yeah, this is actually a backing for the LCA 2021 swag badge, the conference badge. This clips onto the back of it. It's 3D printed. I just happen to have it sitting there. It's not bad as a diffuser. It's a bit of white PETG. Yeah, I could... All right, anyway, back to the point. What I was trying to show you was, if you look closely at one of these LEDs, like let's just pick one, you can see that it is flickering. And I don't mean that the pattern is changing, but every now and then it turns off and then back on again. And if we scroll in the real world, if we scroll over here, look at these LEDs. These are rock solid. They are transitioning through the different colors, but there is no flicker. Everything flickered then because I was moving it, and I think it's I'm bumping the power leads on the back. But down here, even when we don't have the major flicker effect, we're getting little bits of artifacts of things happening. Well, where to from here? Put a couple more caps on and call it done. That would probably work. Take this back out. Move it here. And this is with a very low level of illumination. Now, can I bend those caps? I'm going to turn this power off while I'm doing this, just in case I do something like that and break it off. I'm just trying to move this cap so that I can put it in a position where it's not going to be obscuring any of the LEDs. This is clever. I'm holding a lead while I'm soldering it. Nice warm lead. Alright, so that one's there. Try to bend this cap in such a way that I don't short its leads like I just did, but I can still get it down between the LEDs. There. So these caps are now lying flat against the PCB and not obscuring anything too much. So when the LEDs are on, none of them are being blocked by the cap bodies. Now I could probably add another one up around here somewhere. Yeah, maybe I'll do that. This is one of those things where I'm not entirely satisfied with the characterization of the problem. It all just seems a little bit weird. And yeah, I am pretty well convinced that it is power now. But I would have liked to have seen a little bit more about what was actually going on. So, 5 volts, I'm just going to do it through here. Ground connection, loop that up to 5 volts. That one's ground, yeah, that'll do. There are already some handy 5 volt connections on this PCB. Like that one right there. What can I push down with? That'll do. Alright. And then I'll stick another cap down towards the end. I should be doing this on the back of the PCB, shouldn't I? Which side is which? So we've got ground. Yeah, let's do it. Alright, if I'm going to... I started bodging these on just because it was... it was to test what was going on. But if these caps are going to stay here, I need to put them on the back of the PCB. So, question is the front or the back of the PCB ground and 5 volts? Which way does it go? So it looks like the back of the PCB is 5 volts and the front is ground. That's slightly unfortunate because it means that I can't put it onto the back of the PCB, because basically there's almost nowhere that ground is available on the back of the PCB. Very few places. If I scratch away that silk screen, that's just exposing 5 volts. Oh well, I'll leave the caps on the front. And with the diffuser in place, you won't really see them anyway, I think. So I'm going to put one right down here. Onto this LED here. Power's off, yep. Good. No zappy bangs today. Ah, what? That was disgusting. Heat the joint, apply the solder to the joint. Not the other way around. Ground, yeah, okay. And that one there. I get that the right way around? Yep, marked is ground, so that should be right. All right. Turn on power again. No capacitors go splody boom, which is good. And the sign is stable there. I'm going to reload it, turn the brightness back down. Seems to be stable there. That now looks absolutely totally stable to me. I can't see any flickering. Until I added these last two caps, I could still see a little bit of flickering, but it's now just totally stable. So, I think we can call this one solved. All right, I'm going to turn that back off again because I'm going to revert this data connection back to the short bit of wire that was doing it before, instead of having this long wire looping around. Pull that out. This yellow one is the original data connection. It's got a bit of an ugly end on it. Connect that into D2. Bring it back around. Power on. And now we have a functional sign. Turn brightness back down. Nice and stable. Now there was one effect that that I saw on it. I think it was called worm. No, wipe or chase. There was some pattern in here where chase. That could be it. Where there was a color that ran along it, and that looks kind of cool. So color 1, make it red. Color 2, green. Color 3, blue. Ooh, we're getting flickering again. Ha ha ha. It is not entirely solved. Yeah. Turn it down more to accentuate it, make it worse. And the flickering is back. But it is definitely not as bad as it was before. Now, according to, see, I've turned it up just a little bit more. The intensity is turned up, and now the flickering has gone away. Normally at that intensity level, that flickering would have been really bad. I'm going to stick it back into, what? I didn't notice the time. Right, I'm going to turn that off. I'm going to stick this back into its case and see how it looks now with that diffuser in place. Which way around does this go? Nope, doesn't fit that way. Fits that way. Good. All right. So it's back inside its case. And looking through this diffuser, I can't see those caps at all. They're invisible, which is great. Power back on. And back over this way. Now, brightness down again. All right. Now, it's just a static thing. It's not running a pattern, but you can see that there is no flickering on that now. Turn the brightness right down. So this is on a very low level of brightness now. I can just barely see it glowing. And there is no flicker. But now if we go for a pattern. We'll see if we can get some flicker happening. Oh, that's blink. Yeah, you can see as it transitions, there is definitely a power issue still. All right, so where does this leave us? To solve this properly, I think we would need to put caps all the way through it. It's disappointing that just putting those 4 caps on hasn't solved it 100%, but I'm not entirely surprised. Ooh, this is a kind of cool pattern. Yeah, so where was I? Oh yes. Now, if we go back into Eagle for a moment, and where are we? Pull up the schematic. Now, the way to actually solve this problem would be to do add a part. Hello, there we go. Okay, discrete semi, cap, let's pick an 0805, that'll do, and go, what have we got to connect between VDD, ground, oh, let's just stick it up here. You go doink, 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 and VDD, and oh, it's going to look terrible because of where the tracks go, but this is the general idea. What you do is you take a cap and you stick it, and there are some dangling traces around here. I'll get rid of those dangling traces. Oh, dangling nets. So this is the general idea. What you would do is stick a cap, and we'd make that like 1 microfarad, 1 microfarad. Oh, I didn't link up that last one. So what we do is have a cap across the supply rails of every one of those LEDs. And then back in here, but of course, come on, where you go. Now all of these are in parallel. Essentially these capacitors are all in parallel. They're between ground and the supply voltage. But the important thing is to put them in close physical proximity to, I'm just going to stick them around here. Doesn't really matter at this point. I'm just doing this for the sake of talking about how to solve this. Now if we rat's nest that, what you would do is go zoink and zoink, bring that one through to there. So what we would have is one of these little filter caps on the 5-volt rail of every LED individually. And if you're looking at it in the schematic, the reason, oh, I don't know if you could hear that, that was my stomach saying it's lunchtime. James just said, I'll update the file if you want to pick and place it. Yeah, it'll be a pain doing this by hand. But what on the schematic, this could be represented by just putting a whole bunch of capacitors all in parallel connected between ground and 5 volts and having them off somewhere else. But my personal preference when laying out a schematic would be to put the caps near the part that you want it near. And yeah, when just deleting stuff because I can. I'm not going to save this obviously. So what was I doing? I was thinking about lunch. That's what I was doing. So the idea is that these caps, even though they are all in parallel, like if I do a net highlight, so say show VCC, it's connected to one side of each of these caps. And if I highlight ground, it's connected to the other side of each of those caps. So it's effectively the same thing as if we just, you know, stuck some caps along here and joined all the nets together, like joined them all together. What am I doing? There, and then connected that to ground and connected the other side to 5 volts. Electrically, it is exactly the same. Well, electrically, from in an idealized sort of stylized point of view, that is the same. But and then we can go whoop, boink, yes, merge it, and VCC. I'll stick VCC up here. Yes. So now we've got ourselves some filter caps that, if we went back to the PCB layout, we could then just stick one next to each of these LEDs. And it is the same. But I still prefer to put these filter caps next to the part that they are supposed to be associated with, because it is all about trace length, there and there. And that cap is filtering that LED. And then that cap is filtering that LED. So putting them here next to the LEDs, directly next to them, is not the same as, say, move group, as taking a bunch of these, sticking them here, move, and just linking them all together. The total capacitance is the same, what they are connected to is the same, but it does not have the same effect. Actually, let's rat's nest this. What side of the board is it? There, there, and then we could yoink. Link them all together. Not the same thing. Anyway, I'm kind of rambling now. What did okay, I'm going to get back into these highlighted things. Oh yeah, so cable tie. Actually, I'm supposed to pronounce it cabletti. So from now on, cable tie is cabletti. So I totally agree, this is a little harder, but it conveys the additional info to the consumer of the schematic. Yeah, and that is an important point. I'm trying to think of where I did this just recently. There was some schematic where I explicitly put a note on it saying that I remember what it was, and it's one I can't show you, unfortunately. It was it's a commercial project for a client. I had, in that case, I got some motor drivers, and there are filter caps and various other things. There are some MOVs, and in that what I did was, in the schematic, I put the caps right next to the motor drivers, and on the schematic there is actually a text note that says I can't remember the wording, but it's something like locate caps near related driver and minimize trace length. You know, something like that, because in some situations you'll get someone that comes along and looks at your schematic, and if you just see a whole bunch of filter caps like this, it may not be obvious that they need to be distributed and associated with individual parts, even though logically they are all connected to the same two places. Mr. Cabletti. Yeah. Aaron asked, have you tried to put power on both ends of the lights? Yeah, it's actually injected at multiple places. There are a few different points on the PCB. So the entire planes of the PCB, the front and the back, one of them is ground, one of them is 5 volts, and power is injected at multiple locations on them. So the connection across the PCB is excellent. Oh, interesting. So Robson made the observation, to me it looks like you have a bad LED on your @ logo, as no matter what you do, it always starts leaking from the same place. I would suggest replacing the LED. Yes. Interesting. All right, I'm not going to investigate that further right now, but thanks for the observation. Now, where was... Okay, so many comments that I've missed. All right, so Austin's Creations said, I'm on the fence if it is or isn't as the design is... Oh, this is... Sorry, I was reading this out of order. So, Austin's Creation said, while there might still be a bad LED, but the design in general is missing lots of capacitors, I'm on the fence if it is or isn't, as the design is bad in terms of logic, 3.3 volt logic and 5 volt supply, along with lots of caps missing. So, okay, so intermittent tech, so following on from that, Austin's Creations, after the data signal goes into the first LED, the data signal is then the voltage that LED is getting. If that is 5 volts, then data is 5 volts from that LED on. Yes. And I've talked about this on a previous live stream, and considering that it is now well into lunchtime, I'm not going to go into it in great detail now, but this comes down to what I was talking about earlier with the output buffers as well. So if we just look at one LED in isolation in the string, so we've got power coming in here, this is 5 volts, and we've got ground. Then we have data in, and say you were driving this with a 3.3 volt logic signal, the controller IC in this LED hopefully will read it, even though it's out of spec. In this case it's reading it, but then the controller IC has its own output driver that drives the data out. So the data that comes out of the output pin here will be at 5 volts. Well, it'll be at whatever the supply voltage is here. So if you're running these at 5 volts, as they should be, then the data that comes out of the first LED, I should have used this as the example. So this is 3.3 volts coming into it on the data input. The data out will be 5 volts because the driver in the LED will take care of that. So the only place this is actually an issue is right here on this trace. It is the data coming from the microcontroller at 3.3 volts going into the first LED. After that, it's no problem. So if the first LED works, everything will work. Yes. Oh, Aaron said, I thought a D1 Mini has a 5 volt in pin, right? It does, but it runs at 3.3 volts. So the ESP8266 on a D1 Mini runs at 3.3 volts. It's got an onboard regulator, and you can supply at 5 volts, but it won't run at 5 volts. It runs at 3.3. And then the data pin that comes from it will be 3.3 volt logic. So, oh yeah, and Johnny Bergdahl just said it doesn't actually support 3.3 volt inputs. It just happens to work. Yeah. So, oh, actually, this is a quick test that I can do. Mike Hewitt said, okay, have you measured the supply voltage at the end of the chain? Before I finish this live stream, which I will do in just a moment, I'm going to stick the multimeter on it and measure that the voltage at different locations. I am pretty sure the voltage is going to be the same everywhere, but we'll measure that just to verify. So, what was I talking about? Brain fade. Yes, so let's have a quick look at this. WS2812B data sheet. I'm pretty sure it is 0.7 times VCC. So we can do the calculation. Now, where are we? Power supply input voltage V1. Where's the spec on it? Input voltage level. Yeah, here we go. Look at this. So, and I could talk about this in more detail, but I'm way over time. All right, so VDD. So that's voltage for like the digital data or whatever DD stands for. Yeah, and I know there used to be VA, VB, VC, and the reason we have VCC and VDD is back from the days of batteries and multiple voltage rails. But let's not get into that ancient history. So, yeah, VCC, the naming of VCC comes from the C battery. Not C cell battery, that's different, like a C size. Anyway. All right, so ratings, 3.5 to 5.3 volts is the power supply voltage. So if you're running this, so technically it shouldn't run at 3.3 volts supply voltage. It's running at 5 volts in this case anyway. So let's look at that. VDD, 5 volts nominal. Okay. Input voltage level, minimum 0.7 VDD. So let's do the maths. 5 times 0.7 is 3.5 volts. So according to the spec on this little LED, you need a minimum of 3.5 volts on the input to indicate a logic high. And the ESP8266 doesn't run at 3.5 volts, it runs at 3.3 volts. So technically we are slightly out of spec by driving the LED. Now luckily WS2812Bs are fairly forgiving in that respect, and as you can see it's working. Alright. I'm kind of just meandering around at the moment. I really should just wrap this up. Okay. What other comments have I managed to overlook in all of this? So Mako said, still not sure if the caps filter the noise on the data line or just help a dodgy pixel overcome its troubles. Pretty sure it's in the @ sign. Yeah, and many people have said that there seems to be a problem in the @ sign somewhere. And Dodgy Brothers said, feels a lot like a Band-Aid rather than solving the problem. Yes, exactly. That was what I was very badly trying to say earlier when I was feeling dissatisfied with just sticking caps on it and having it go away, but not really making it measurable. Oh, Intermittent Tech said, stick caps on before the problem. Yeah, add a cap in the logo, Johnny Bergdahl suggested. Oh, and Stephen Whitaker asked what value cap was that. I didn't even see that. I think they're 100 microfarad, or were they 10 microfarad electrodes? I basically just grabbed whatever I didn't even pay attention. 100 microfarad 25 volt electrodes, which are not the ideal thing for this, because electrodes have a higher ESR, or equivalent series resistance. And all right, I'm going to do it. I've got people shouting at me to add caps before the problem and in the @ symbol, so let's do it. All right, so Apostolos suggested, can you lower the voltage from your power supply without creating a problem to the circuit? Now, that is a really interesting idea. All right, there are a couple of aspects to this. There are squirrels I could chase. If you run a WS2812B LED at 4.2 volts, then it is within spec for its operation. And if you take 4.2, so 4.2 times 0.7, it means that it only needs 2.94 volts on its input to see a logic high. So if you take WS2812s and you run them at 4.2 volts and connect them to an ESP8266, it is within spec for the LED for its power rating, and it is within spec for its digital input. So that's one solution, is you run them at a slightly lower voltage. But let us mess around with that and see. How can we, let's get this, all right, I'm going to get this flicker happening again. You can see it's just flickering lightly, but I'll try to, what pattern can we use? Breathe. No. Now that it's not doing it, I want to see if the supply voltage affects the flickering in any way. It's solid, not Android. I might have to take it back out of its case to remove the diffuser. In fact, what I'm going to do is I'm going to remove a couple of those filter caps. Because Apostolos' comment has some interesting implications. So let's get rid of this filter cap and this one. Not totally removing them, I'm just taking one of the pins off. And then we'll see if we get any flickering effect on this. We won't at that level of illumination, that's for sure. Because WLED has dropped back to its default. Alright, I want to try to get some flicker happening. Come on, give me some flicker. Will blink rainbow do it? No. Oh, hang on. I'll set a couple of different colors on blink rainbow and see if we get some flickering. No, it's just blinking. Now, where was the pattern? Oh, palette, that's right. So palette was the one that we were using earlier that I think was showing the problem. No. I might have to disconnect those other caps as well. Alright, I'm going to disconnect this one. This is the one that's closest to the origin of the problem, I think. And as people have been suggesting, I should be putting a cap over here somewhere. Alright, let's turn it back on. See if we can get this flickering happening again. Come on, give me some flicker. I think I'm going to have to disconnect all of the caps. Okay. We've band-aided the problem effectively enough that it's all working. Have I disconnected them all? Looks like it. Come on, give me some flicker. There we, oh, I saw a flicker for a moment. I'm going to set some different color options in the palette. Make that one red. Oh, come on. How is it that we were having terrible flicker earlier and now it is working? and I can't reproduce it. Give me some flicker. Flicker. Bouncing balls. Just trying some different patterns. That one's no good. You can't even see it on the camera. And it's not really a useful one anyway. Candle multi. How is it that... Ah, okay. I think we got it. Yes, we got some flicker at the end. Hooray! And flicker is back. All right, so you can see that it's flickering in this section here. I am going to turn down the voltage on my power supply. So it's currently at 5.00 volts. I'm going to make it 4.5. And the flicker has almost entirely stopped. You can see a little bit happening through here. I'm going to set it to 4.2 volts. And the flicker has gone away entirely. It's on. It's just like a nice consistent blue. And so I'm going to change to, okay, VSET 4, okay, that's 4.2, 4.3, 4.4, 4.5, ooh, now there is some flicker starting, 4.6, 4.7, 8, and now you can see the flicker is a bit more consistent, 4.9, 5 volts. Well, that's interesting. So running it at a slightly lower voltage could also help solve this problem. All right, I'm going to reconnect these. No, before I reconnect these ones, I'm going to connect one only down here somewhere inside the @ symbol. Where did I stick that other cap? Now, where's a good spot? So it'll be interesting to see the effect of a single cap that is back up in this area somewhere. Maybe that one. I need one that is in a location where I can bend the cap into a position where it's all out of the way. But also one where I can get to its, where I can get to its ground pin easily enough, and its 5-volt pin. Maybe that one. No, don't like that one. Come on, how hard can this be? Got to find a spot where the angles are all just right. 12. Yeah, I'm going to try this one. Okay. That LED there is where I'm going to try to add the cap. It's a little bit awkward, unfortunately. Get this in there. You can see the plastic melt very quickly. No, not that one. I want that one and that one. So, which way am I going to orient this? There. It's kind of a shorting danger with this position. I know what I should do. Before I solder this on, so while we still have 0 capacitors, I'm going to measure the voltage at different parts of the board. Alright, unfortunately you're not going to be able to see the multimeter, but I'm going to turn on power and I'm going to measure, oh it's so bright, where's the connection? Ground, okay, so 5 volts and ground right at that point. What? How is that measuring 2.7 volts? What? Unfortunately, you can't see my multimeter. Is that mislabeled? Is that a data connection? Okay, let's try from there to there, 2.7 volts DC. I wonder, yeah, so these caps are possibly just compensating for a much more serious issue. Alright, let's put this on so you can see what I've got here. So I've got 5 volts. What have I got at the end of these? 2. How can there possibly be that much voltage drop? What is going on here? Alright, I'm going to disconnect this. And put that on there. 5 volts. That is... This is one of those classic things like, did you turn it on? I just didn't check the supply voltage right at the start. Okay, I'm going to disconnect this. I'm going to do something different. I'm going to go for... what leads do I have? That one? That one. Yes, I want this one. I'm going to bypass the leads that I had coming out of my power supply. I'm jumpering straight into the output. Okay. Where are my test probes? There. 5.000 volts. I'm reading across that. And now I'm going to connect it to this and to this. And what am I reading? 2.9 volts. What is that? As an old friend of mine used to say, is that for serious? So are we getting that much voltage drop in these leads between, it's like a 40 centimeter long lead. The lab supply is right here. It's just out of field of view of the camera. And I'm now measuring 2.9 volts across that. Hang on. Was it going into... I'm just really confused now, and I think I need to stop for lunch because the display on the lab supply was showing 5 volts. I'm going to set it to a 5 amp current limit. Turn it on. Let's see if smoke comes out. Nope. So the power supply claims that it is outputting exactly 5 volts. We're now getting 4.2 volts at 3.8 amps. Why was I only getting like 1.7 amps out of this earlier? The mystery continues. Okay, I could be here for another hour, 2 hours, screwing around with this. We're already heading towards the end of the 3rd hour, so I am going to stop. Yes. Are you drawing 100 amps? Not quite. I'm going to stop. Oh, hang on. Johnny gave a link to a hack. What is this one? Control thing using a... Yep. Oh yeah, that's the diode hack. Yep. So I talked about that in a previous live stream. So this runs the first LED at a slightly lower voltage. Sorry, I'll switch to desktop view for that. So the first LED runs at a slightly lower voltage, which brings its data in within spec. So this is kind of what I was talking about before. And then all of the subsequent ones run at the proper voltage. Alrighty, I'm going to stop now. Mike Hewitt said, I think it's time for lunch. Ah, yes. Yeah, it could be more than 5 amps, but the thing is that I've been running all of these at very low brightness. Like the slider has been right down near the bottom because I've barely had it turned on. All right. Dodgy Brothers says, can't see the forest for the trees. Yes. Yeah. Okay. I am going to... I'm going to call it because I need lunch. So, thank you for coming along on this magical mystery tour. It was not very well organized or structured, and I tried a few things that, anyway. I was not really going about it in a very logical way. But it's kind of fun just to poke around in these things and see what's going on. I'm going to have lunch. You should too, if it is time for lunch for you. And I will see you next week. So, thanks for coming along. Now go and build something awesome.